One of the neat features in the Arduino Zero is that the resolution of its PWM analog output can be configured. While in the Arduino Uno, the PWM resolution is fixed to 8 bits, in the Zero you can set it to any resolution up to a maximum of 12 bits. In this lecture, I'll show you how to set the PWM resolution in the Arduino Zero and look at an example of a PWM signal on the oscilloscope. Let's start. In the Arduino Uno, with the Atmega 328P microcontroller, you can simulate analog signals using Pulse Width Modulation, and the resolution is fixed to 8 bits or 256 different duty cycles. The Arduino Zero with its SUMD microcontroller has PWM, of course. It also has a true digital to analog converter, about which I'll talk in a different lecture. But the main difference between the PWM of the Arduino Zero and that of the Arduino Uno is that the resolution is selectable. You can go up to 12 bits of resolution, which gives you a total of 4096 different pulse width modulation duty cycles. And that is selectable to other values. For example, you can go down to 4 bits if you really need to, or you can default to 8 bits, which is the resolution of the Uno, or you can go to 10 bits. All that is configurable. To change the PWM resolution on the Arduino Zero and in other Arduinos that also have the same capability, you use the analogWriteResolution function. You can see here that in the case of the Duo, for example, again I'm looking at the Duo in a different section of this course, we have the ability to configure PWM pins to 12-bit resolution maximum, and you have the same resolution on the Arduino Zero. So 10 pins have the PWM capability, and all of them can be configured to whichever resolution you like, up to 12 bits of resolution. Let's have a look at what PWM at 12 bits of resolution looks like by using a demo sketch and my oscilloscope. First, I'll just use the default 8-bit resolution on the Arduino Zero, and to do that I just use the analogWriteResolution 8. I don't really have to do this because by default the PWM resolution is set to 8, but just to make explicit for the purposes of this demonstration, I'll just explicitly set it to 8. And then I just use 2 loops, one to increase the duty cycle from 0 to 254, and the second one to decrease it from 254 down to 0. Let's connect the Arduino via the programming port and upload it. Okay, done uploading. Got the Arduino pin 11, the PWM pin 11, connected to my oscilloscope channel 1, and I'm just going to hit auto to begin with, just to get it to calibrate itself. And you can see what 8 bits looks like in PWM on the oscilloscope. It's pretty gradual, 256 individual steps by which the duty cycle increases or decreases. Right, okay, let's have a look at what 12 bits look like. So the only change in the sketch is that in the 12-bit sketch I set the analogWriteResolution to 12 bits, and that means that the 2 loops go from 0 to 4095, and then decreasing from 4095 down to 0, and I stay for 5 milliseconds at each step. So let's send that up to the Arduino. Okay, there you go. So that's what 12 bits of resolution look like. We now have to go through 4,095 different steps in the 2 loops, so it takes longer for the full duty cycle to appear on the oscilloscope. So the difference between the 8-bit PWM resolution and 12 bits resolution is that in 12 bits you've got a lot finer control of your duty cycle in your PWM signal. Of course, the question is, what can you do with those extra thousands worth of steps in PWM? I don't have a good answer to this. Some people suggest that with this additional resolution you can have finer control on things like LED lighting setups, and you can create more natural looking RGB colors with your LEDs or finer motor control. I don't really know. I've never actually needed such fine resolution myself, but it does exist just in case you've got a special project that needs it.